So this again was the old incubator, and one thing I forgot to mention about the old incubator is that the eggs also have to have the right humidity in there, and I also had to manually wet these sponges, and I put not zip ties, I'm sorry, I put these metal little wires, and I put them around there and I stuck them to the wall, and I did that every time I turned. I had to re-wet them every time I turned the eggs, which is also pretty inconvenient, but not as inconvenient as having to rotate the eggs and move the electronics around. And another thing I forgot to show you guys is the basic circuitry that I did for the temperature control. So here's the basic stamp 2. It's hooked up to whenever we want to program the DS1620 temperature sensor. We hook it up and we type in our code and write the desired low temperature and the desired high temperatures, and we power that up with 3.3 volts via this voltage regulator. And then once this is running, it'll act basically like a thermostat, and this will go on and turn on the red LED whenever it's too hot. This one will turn on the yellow LED whenever it's too cold, and the T common will activate this voltage divider to activate the transistor here that activates an even bigger flow through the coil of this relay, and it powers up the 100 light bulb that we have there. So that's the basic circuitry of the temperature control. Now moving on to the new and improved incubator. Here it is. I have switches here. It's not completely done. It's still a work in progress, but there's a lot of improvements here. So this is a double pane window here for sure. This is glass. I got this from a picture frame, 99 cents at the store. And here's the other one, another little picture frame, also $1 at the 99-cent store. And I insulated it with a type of foam all around to better seal the double pane window. I placed hinges here to make the door up there, and instead of just mounting the light bulb like I did here in the first design, I've put a light bulb mount here, which is also not very expensive either. It's $1.50. I think I got it at Home Depot. And these are old computer fans that were gonna be trashed, and I'm recycling them, and so was that. And this will have a forced convection inside the incubator to, I think, better maintain the temperature all across the incubator. And this is going to be the main power supply. And another thing here that I really, I guess, didn't like was the fact that I had to plug in two things. I had to plug in the light bulb independent of the circuitry. The thing that's going to be different here is that I'm only going to have one power cord, and that's going to power up the entire thing. So let me show you more of the heart here. Oh, I've also placed that same foam all around here to also add better seal to the incubator. Another thing I'm going to do to the incubator too is add that same tape that I added here, and that'll hopefully help maintain the temperature more stable inside of the incubator, which is highly desirable. So I have this black panel here that's going to be used later once the chicks are born. I'll come back to this later. Let me talk about this incubator first. So here is a regular threaded rod, and as you can see, when I turn it, it lights up that little LED there. And that's just due to the induction that is occurring through the coils of the stepper motor there. So I've mounted the stepper motor. I've coupled that with a regular coupling nut. I made some holes. I threaded them, and then I put some insert nuts to keep both this threaded rod in place with that, and also keep the shaft of the mortar in place with the coupler nut. And this runs through a bushing here, and it runs through a regular hex nut that I've put on the other side, and it has also another little bushing on the outside here. I was gonna make it closer to here, kind of a mishap, if you guys are wondering why that hole is there. So there's my threaded rod, and whenever this turns, we can see that the rack that's going to push the X moves with it. And I've placed just a regular metal rod there with bushings here and here to kind of keep the rack from going up and down or moving too much, kind of to help stabilize the rack. So I'm gonna put the circuitry here, and if you guys can see here, I've also made like a little window, which is where I'm gonna put another fan down there in order to hit this H-bridge directly, because this stepper mortar consumes a significant amount of current, which when it passes through the H-bridge converts into heat. And that's why it's got this huge heat sink here. And this H-bridge is a L298. I got it offline for like $5 from IC Station, and they're a good website to buy from. Anyways, I'm gonna place this right here and put a fan directly on it, because this thing gets really hot whenever I'm running the stepper mortar. So that's gonna be the biggest change between this and this, that I'm gonna have an automatic egg turner, and I have some limit switches that I'm gonna use that are gonna be placed right here, such that whenever this thing is turning here and it reaches the very far end here, it'll cut the power off to the circuitry delivering the power to the mortar in that direction, so that it doesn't continue trying to push there, overheat the mortar, or overheat my H-bridge, or potentially damage the eggs, or potentially damage any other part of the incubator. And it'll be the same exact thing on the other side. I'm going to have another limit switch so that it cuts power off to that same side, pushing the stepper mortar. So